Hi there, it's again Kid. Although today is a busy day, I've got a request from one of you wanting me to break down the 2013 higher level paper 1, question 9 and question 10. And since it's really close to the IB exam, I decided to do almost an emergency breakdown. I'm gonna break these two questions down, okay? So the first question are basically two equations. One is a log equation. The other kind of is an exponential equation. So both would be related to log. Okay, so it's a log equation problems. Okay, so asking us to solve these two equations. Okay, so let's do A first. So for log equations, whenever the log are different, there isn't much that you can do except the change space formula. Okay, so bear in mind that there isn't too many occasions that we actually use the change base formula. It's only when in the same equation or same expressions you see two logs with different bases, then we will use the change base formula. Okay, so the change base formula is actually inside the formula booklet. It's like log b base a would be b on top, a at the bottom, log b over log a. And the new base is up to your choice. As long as they are the same in the numerator and denominator, it's alright. So you can choose your own base to be the new base. Okay? So this is what we're gonna do on these two bases. Okay? So some people may change the base for both of the base and just be lazy and just choose C to be 10. That's the same as not writing it, right? Because for log, if we don't write the base, it's base 10. But if you have seen other people doing this, okay, maybe you've seen a solution or something, you will have seen that the best base, I made a mistake, I should change the base here. So we use the change base formula on the right hand side. So this big thing would be our B, this base is our A, so it's equal to log B over log A, which is 4. You have found that the new base, the best choice of new base is probably 2. Why is 2 good? First, it makes the bases the same for the whole equation. So it would give us a new opportunity to actually solve this equation. The second good thing is log 4 base 2 is calculatable. You can actually tell the value of log 4 base 2. So I assume you have basic knowledge of log and you're successfully obtaining the value 2. So you multiply 2 to the other side. So after changing the base to the same base, I imagine there isn't much difficulties. But just go through the general steps of doing logs equation. Whenever you do log equation, you want one log equal to one log so that you can delete the two logs. Okay, except in front of the log there cannot be anything. Therefore, the next thing you need to do is you need to put the number in front of the log up to the power. So you do this. Then you can just delete the log on both sides and expand this. So I also imagine you can expand a bit. Okay, so x2 and x2 cancel out. Move 6x plus 6x to this side, 2x equal to 8, x being 4. Okay, whenever you do log equation, you have to be careful if this value would actually work. What I mean is you have to plug it back in, see if any of the logs becomes the value inside the log becomes negative or 0. A quick check would see that they won't be negative nor 0. Okay, so 4 is accepted as an answer. So whenever the base is different, use change base formula. The second one is a little bit more tricky. It's not any common type or standard type of equation. It's just, well, playing some trick with it. So part B is x to the power of ln x, okay, equal to e to the power of ln x to the power of 3. Okay, now note that this bracket is necessary because if you just write ln x to the power of 3, what you mean is you power the x first, so you write x to the power of 3 first and then log it. But what this means is you log the x first and then cube the whole thing. So it's really different and you really need this bracket. Okay? So Although there isn't an obvious way of doing this, I guess most people eventually, trying some way or the others, would try to lock both sides. It happens to be a really good strategy because if we lock it, lock this. We lock it, two things would happen. First of all, log and e to the exponential cancel out. Okay, what do I mean? What I mean is I would be using the following identity. Identity that is e. If you log e to the power of x, okay, you would just get x. Okay, just the power. The log and e cancel out each other. Okay, so what happened on the right hand side is you have just the top left. What happened on the other side is this is a power. Whenever you have a log, you have a power. The power can drop down as being multiplied to this log. So it's log x multiplied to log x. But what is log x times log x, right? It's obviously log x whole square equal to log x whole cubed. Okay? Now this becomes something that we can solve. Alright? So what can we do now? Okay, one thing that we cannot do is actually divide log x squared on both sides. We cannot do that. Why? Again, you can never divide 0. Okay, you can never divide anything by 0. Okay, therefore, if you just take this example, x squared to x cubed, can we just divide x squared on both sides? The answer is no. Okay, no. Why? Because x squared have a chance of being 0. Okay, if x squared is 0, x cubed is of course also 0, so 0 equals 0. X squared equals 0 is actually a solution to the equation. That is, if you divide anything that could be 0, okay, that's illegal. You cannot do that. Okay, so how do we do this? The general way would be you subtract this to the other side. Okay, factor out the ln x squared. So this cubed squares out, so ln x minus 1. Okay, so two things multiplied together get you 0. That means ln x squared is 0, or ln x equal to 1. If ln x squared equals 0, of course ln x is just 0. And if ln x is 0, okay, x is just 1. Okay, or ln x is 1, that means x is e. Therefore, x could be both 1 or e. Okay, so that solves the solution. So this is not really a standard kind of equation that you see all the time, but I guess it takes a little bit of creativity, okay, because it's after all the higher level. Now we jump right to question 10. Question 10 is a section B question. It's a long question, and it's a quite standard curve sketching question. Okay, curve sketching by doing differentiation to find maximum minimum, and then second D to find point of inflection. Okay, and then you can sketch graphs. Okay, with a little bit of functional transformation. That should be small stuff. So let's get going. So they give you a function x e negative x. Okay, they want you to find the derivative of x. So we just do it with cross product rule. So keep the first one, differentiate the second one, chain rule negative. Okay, differentiate negative x give you negative, plus keep the second one, differentiate the first one, differentiate x is just 1, so it's nothing. This is the first derivative. Okay, hence determine the coordinates of point A where f prime x equal to 0. So I want this to be 0. So like this. Okay, I can factor e to the power of negative x out. So it's minus x plus 1 equal to 0. So it's either this being 0 or the bracket equal to 0. But the problem is, for a positive number, e is a positive number, put any power, it would never be 0. So this can actually never mean 0. So we have negative x plus 1 equals 0. So x would be 1. Okay, so x is 1. They want coordinates. That means they want both x and y coordinates. So we plug it back in. It would be 1e minus 1, 1e to the power of minus 1, which is 1 over e. So the answer is 1 over Next, expression for double dash, so second derivative. So what we do is we differentiate this again. Okay, that may take a bit longer. So let's do it here. Okay, for the derivative, so we need to differentiate. Okay, this thing. Okay, of course, this is again product rule, and this is just f itself without the negative. So when we differentiate this, it's just negative of the derivative of f, right? Plus differentiating this. Okay, differentiating this would give me negative e negative x. Okay, because the negative comes from chain rule. If we differentiate inside, we get a negative. Okay, so negative, negative, positive, minus equal to x e to the power of negative x minus 2e minus x. So that's the second d. Okay. Using the second d, right? Using the second d show that a is actually a maximum. Okay, how do we do that? We plug the x value of a into the second d. Okay, so f dash dash 1 equal to 1e negative 1 minus 2e negative 1. So it's 1 over e minus 2 over e is basically 1 over e times, sorry, it's negative 1 over e. The denominator is the same. We can just do subtraction. E itself is positive, all right, so the overall is negative. Whenever the second d is negative, the stationary point would be a maximum. Therefore, it's a maximum. Okay, done. Okay, find the coordinate of b, a point of inflection. How do we find point of inflection, right? Of course, we take the second d and set it be 0, right? So we take the second d there. So it be 0. Again, this thing can be factored out. But again, this cannot be 0, so x equal to 2 is the x coordinate of the point of inflection. And then we need to see, what's the y coordinate of b, right? So plug it back to the original function. The original function is here, so f2. 2e. Okay, so that's it. So this is 2, 2e2. And you may ask, why didn't I need to do the side diagram to check if this is actually a point of inflection? Okay, the secret lies in how they ask the question. If they ask you to find the point of inflection, it's assumed that a point of inflection exists. And since I got only one possible candidate for point of inflection, we can automatically assume that it's actually really a point of inflection. So it's a secret of how IB would formulate the question, and depends on how they ask it, you will need to show by the side diagram if it's actually a point of inflection or not, or actually a maximum, minimum or not. But if you have any doubts in exam and you want to play safe, I really suggest you do the side diagram anyway, okay? In real exam. So let me show that process. So what we do is we test numbers that's bigger than 2 and smaller than 2 to the second derivative. Okay, sorry, this is x. The second d is this one, this original one. Okay, so it's basically this one because I just factored this out. The secret is, since e is positive, positive numbers to any power, even if negative power, is always positive. Therefore, this term is always positive. Okay, so it's obviously, you see that if x is bigger than 2, then the whole thing would be positive. Okay, that's 3 minus 2. But if it's less than 2, like 1 minus 2 is negative. So negative, positive, there's an obvious sign change. So if you want to play safe, I really suggest you to take like 30 seconds and write this down. Okay, so that's point of inflection. D, the graph of G is obtained by doing a transformation, stretching it in x direction by scale factor 2. Okay, so it's affecting x, so obviously you're going to do the transformation 2, stretch scale factor on x, except everything happened on x would be like the opposite. Therefore, instead of multiplying x by 2, you divide by 2. So it's x over 2 e negative x over 2. This is basic functional transformation. Okay, read your notes if you are not sure about this. State the coordinate of the maximum C of G. Okay, G obtained by stretching f in x direction by scale factor 2. Therefore, all the point would be stretched, would be multiplied by 2 on the x coordinate. Therefore, what you do is you multiply x by 2. But note that since the transformation only happened on x direction, the y value would be the same. So it's 2, 1 over e. Determines the x coordinate of D and E, where the 2 points is where fx equal to gx. So we need to solve the equation where fx equal to gx. Okay, fx is xe negative x, gx. Gx here. Okay, so how do we do this, right? Because there seems to be something happening over here. Okay, maybe we multiply to the other side. Okay, and this is basically over e to the power of x. What is this, right? So the 2 go to the other side, so this x over e to the power of x over 2. Okay, we do cross multiplication to 2x e x over 2 equal to x e x squared. Okay, so of course we minus this to this side. Note that again we cannot cancel the x because x could be 0. We can never divide anything that could be 0. So factor x out, so x equals 0 or 2ex over 2 minus e to the power of x equals 0. Okay. Okay, so x equals 0 or this bit equals 0. Okay, how do we do this? So like okay, move e to the power of x to the other side. Okay, so we can divide this over because e to some power can never be 0. So we can divide this. Divide. So law of indices, divide is minus, right? So x minus half x, which gives us half x. Okay. Then we can square both sides. So it's 4 equal to e to the power of x. We're squaring. 2 times half is gone. So that we log both sides. X is ln4. Okay. It seems like the second answer is ln4. So C and D, okay, they want the x coordinates only. So one is 1, the other one is ln4. Okay. So then part E, we need to sketch the graph of y equal to fx and gx on the same axis. Clearly show A, B, C, D, E. Okay. So what I would do is let's sketch fx first. Okay. So you know x is bigger than 0, bigger than or equal to 0. So fx. Okay. So first you need to note where is the x-intercept, right? Obviously there's only one x-intercept, x being 0. So first I start at 0. The maximum points go to 1. Okay, so 1, 2, I can't see it. 3, 4 maybe. Okay, so there's a maximum point. Let's say this is 1 over e. Maximum, after maximum you drop at 2 over e squared. Okay, so I don't know, roughly here we need a point of inflection. So you need to show a little change of concavity, right? So this should be f. Where's g? G is just a stretch of scale factor 2 in x direction of this. So 1 here, 2 to 4. So it's like this. Okay. The intersections have a 1. What do I mean by 1? No, the solution was 0. I mean 0. Okay. Make a mistake there. So you can check. It's actually 0 and log 4. Okay. Okay, log 4. So this is 0. They get meet here, and here log 4. Okay, done. So A, B, C, D, E. Right? I should mark this point. So this A, this is B, 2E. Okay, and then this is 2, 1 over E. This would be 4, 2 over E squared. This is D, this is E. Okay, that's the graph. So final part, I found the exact value of the area bounded by, okay, curve G of X, x-axis, and the line x equal to 1. Basically this area, okay? Just G of X. Okay, standard integration will do the work. So let's do integration. So let's see, I need to integrate G with G. G is this, G is this. Okay, from the x-axis, so it's here from 0 to 1. 0 to 1, right? From 0 to 1. Okay, how do I integrate this? Okay, this is very much a standard by part question. Okay, so I don't know how you do by part because different school really might teach different version. I mean, different method of doing by part, I guess, but you will get the same result. So what I would do is I try to use the formula given by the HL formula booklet. Okay, this is V du dx. Okay, so this is the formula for by part. So what you need to do is in this thing you need to decide which one is your u, which one is your dv dx. Okay, what your v prime. Okay, so what we do is whenever we see e to the power of something, we will always choose that to be v prime. Okay, so we take u to be x over 2, v prime to be e to the power of negative x over 2. What we need to find is we need to find the derivative of u and also v itself. That is, you need to integrate v. Okay, so that is what you got before you differentiate. So integrate. Okay, integrate this is obviously itself divided by the coefficient in front. Okay, I hope this is easy to you. Okay, this is basically integration by substitution by letting u to be the top. Okay, standard substitution. Okay, and then u dash just half, right? Half. Therefore, by the formula by part is uv, so u times v, so it's x over 2 times, I flip this on top, okay, negative 2e negative x over 2 minus integrate v is this thing again, so negative 2e negative 2 times times u dash is half dx. Okay, by part formula. So 2 and 2 cancel out, negative x e 2, okay, negative positive, 2 and 2 cancel out, plus integrate. And then you may ask, what about the limits? Okay, what about limits for by part would be, for the first part you use the limit, second part you also use the limit. Okay, so here I need the square bracket 0 to 1, 0 to 1. Okay, plus 1 in is minus e to the power of negative half, plus 0 in, this is 0, gone, plus integrate this, we have just did this, it's basically this thing. So we know is negative 2e negative x over 2, 0 to 1. So this equal to negative e negative half power minus, let me see, okay, let's be careful, alright, plus minus 2 plus 1 in plus 0 in, you minus that, so minus positive, okay, 2e to the power of 0 is just 1, 2 times this. Right? So this would be 2, you minus 1 minus 2 to minus 3 e to the power of negative half. Okay, so that's it. That seems to be The area, is this negative? This is root E. E is roughly 2.718. Root 2 is roughly 1.4 times 3. Wow, this is actually quite suspicious, you know. If you have a calculator, you may want to help me check. This end up to be negative, but I think this is correct. So you can see, some people say, you know, this is the last paper that you get for the old syllabus. So I don't think that the questions are too strange or too complicated or too creative or any kind of extremely new kind of question coming out. So I think the new question really just concentrate on the specimens paper. So I did a breakdown on that already, on the new syllabus questions. So now it's the last days of the exam. If you are gonna prepare for this year IB, so really concentrate. And I got one advice for you. If the day before the actual math exam, alright, just for math, do not sleep late. Okay, go to bed early. Don't try to do some extra math the night before. I can tell you it wouldn't help. Just try to sleep more. Okay, get a clear brain. You know, do the same. So that's it. This is a breakdown of an emergency breakdown, nearly due to the request of one of you, one of the subscribers. So you can keep sending, giving me requests. You know, I will try to do it really. So that's it. Good luck.